All right, good evening, guys, and I welcome you to another ALP session hosted by the Energy for Me team under SPE LASU. If you're excited and if you can hear me, can I please get your virtual reactions, please? Can anyone hear me? Can everyone hear me? All right, thank you, David. Thank you, Donna. Thank you, Sylvester. All right, so real quickly to officially welcome you guys and to kickstart this session, we'll be having our welcome address by our president of SPE LASU in the person of Agose Sylvester. So, Mr. Sylvester, you have the floor, sir.
All right. Thank you very much, Mercy. Good evening, everyone. I hope everybody is doing all right. As for me, I had a very stressful day, but I'm glad to be here. I'm glad to be here. I also want to first off apologize for the delay we had getting this session started. We had to postpone this session by 1 hour due to technical issues, but we're glad that we are back and we are active for this session. All right, so I want to welcome everybody present here for this session on mastering the art of research, because many of us know that SP is gradually entering the season of research writing, article submissions, and it's necessary for us to understand the art and the act of research writing. And we have a very wonderful guest, a very experienced guest, a young person like every single one of us as well, to take us on this very interesting journey of research writing. And I hope every single one of us is ready to learn as much as possible and apply the knowledge that we have gained from this session. So without further ado, I want to welcome every single one of you to this session, and I hope we have a wonderful, wonderful time together for the next 1 hour, 30 minutes. So yes, thank you very much and have a great time. Over to you, Mercy.
All right, so thank you for that one, Mr. President. So, as Mr. President has rightly said, welcome, welcome, and welcome. All right, so before we begin, you know how SPE does it, right? Safety first, always, even online. So, to take our safety brief, will be our Energy for Me lead in the person of Famuyide Demilade. So, Miss, if you're on this call, you have the floor, please.
All right, good evening, everyone. I hope everyone can hear me.
Yes, we can.
All right, so I move on. So the very first instruction, please mute your mic when you're not speaking. Then if you have to speak, please use the virtual hands button to raise your hand. Use the chat button for questions or comments. Ensure you can still hear the fire alarm with your headsets. Always stay safe and be alert of and maintain a good sitting posture. Thank you.
All right, thank you for that one, Miss. So, as you've rightly heard her, please mute your mic until it's probably time for you to speak. And if you have any reservations or if you have anything to say at all, you can always use the chat box. All right, so thank you for that one, Miss Demilade. Now, for the time we've all been waiting for, all right, so we'll be having our speaker on the call right about now in the person of Mr. Oluwatosin Kolade. Mr. Oluwatosin is a mechanical engineering student at Obafemi Awolowo University with interest at the intersection of astronautics and robotics. He has co-authored several papers presented at local and international conferences and is currently working towards two journal publications. In 2024, through the research experience for Nigerian engineering undergraduate Renew, he completed a remote research internship facilitated by Pritzker School of Molecular Engineering at the University of Chicago, where he conducted transmission electron microscopy (TEM) and convergent beam electron diffraction (CBED) simulations to study silicon and gold nanoparticles for catalytic, chemical, and electronic applications. Later in 2024, his team received the Best Research Award in Space Manufacturing for their work on ZBLAN glass and other semiconductors produced in microgravity vessels on Earth, a project that was subsequently presented at the Dubai Futures Forum. Across his bachelor's degree, Oluwatosin has worked on a wide range of technical platforms spanning parallel manipulators and robotics, drones, space structures and fluids, as well as physics-informed machine learning frameworks for energy systems. Right, so I told you guys this session is not just going to be any session. So, if your hands are not too busy, and even if they are, can we have a virtual round of applause for our speaker for today's session? All right, thank you guys so much. Thank you, thank you, thank you. So, Mr. Oluwatosin, you have the floor, please.
Thank you very much. Can you confirm if you can hear me, everyone?
Yes, we can.
Okay, great. So thank you very much for the introduction, and I'm very happy to be here. First of all, let me apologize for the 1 hour delay. So unforeseen circumstance, I have to travel. My professor just be with me. Those we have to reach Ado Ekiti, and so I have to just answer because he's my professor. So I just could not make 6 o'clock, and yeah, I'm really sorry about the inconvenience. So please forgive me. And to show my remorsefulness, my so maybe during the session we can have maybe a giveaway. Maybe I'll just throw questions out randomly. So we can have like 3 questions where like you have to like it's like a giveaway session, something like that, because this is going to be like a very technical. I want to be doing much presentation. Like I'm going to be like showing you exactly what you are to be doing. So from the technical and the hands-on experience, we get to ask ourselves questions, and I can do a data giveaway for 1 or 2 people. So again, I'm so sorry about everything, and yeah, please can you confirm you can hear me again? I'm just being paranoid right now.
All right, sir, we can hear you. We can
Yeah.
hear you. We can. And
Okay.
your sins have been forgiven. Right.
Yeah. Thank you. Yeah. So let me share my screen. Yeah. Please confirm if you can see my screen rather. Can you see my screen?
Yes,
Okay.
yes, we can. Yes, we
Great.
can.
Great. Yeah. So yeah. And once again, thank you very much for the honor to be here. Thank you, the outgoing LASU SP President Silas. Thank you, the new President Sylvester. Thank you to the academic chair. I think it was underfacilitated. I'm not sure. Thank you, Mercy, for the moderation. I like the way you are giving so much energy, and I really love it. You are matching my vibes. So yeah, thank you to everyone,
Sure,
the
that's it.
the attendees, and I hope you enjoy the session. So I'll be speaking on mastering the art of research. Like they said, my name is Oluwatosin Kolade. You can call me Tosin. I'm an undergraduate researcher. I study well. I'm convoking next month. So, but since I've not graduated, I still kind of see myself as a student. So forgive me for that. So yeah, I studied mechanical engineering at OAU, and yeah. So without further ado, let me just dive straight into what we have to do, because we have a lot of technical things to, a lot of hands-on like things to do. So yeah, so now the first question we should ask ourselves is, why should undergraduate students care about doing research? You always see people on LinkedIn or I don't know, ResearchGate. You say, oh, I'm happy to announce that my paper has been presented at a particular conference, or my paper has been published on one particular journal. And you just ask yourself, why are they doing all of this, and how can I, as an undergraduate, how can I, join in the train, right? So now I'm going to give a kind of disclaimer right now. I know everybody wants to write, everybody wants to write the paper, right? But there are some things you need to know before you get into writing, and we're going to like do that after the slide. So the first reason why undergraduates like you and I need to care about research is because it builds your thinking, your critical thinking, your analytical thinking, your skills. It builds your writing skills. It helps you to be able to connect dots together. Oh, you read this particular book, you saw your knowledge there. The next paper you read, you saw that knowledge. So research helps you to just gather your thoughts together, to connect the dots, That's what research does. And as an undergraduate, you are learning a lot of things. You need to know a lot of things for your exam, for your personal purpose, for your final year project. So it just helps, it just makes you smarter, right? Second of all, it prepares you, of course. This one is a no-brainer. It prepares you for graduate studies. So those of you that want to go to grad school for your master's, for your PhD, I mean, being involved in undergraduate research is, I mean, it's very advisable. I mean, you just have to, because I mean, you want to go and do a master's or a PhD, say in the United States, of course, they need to know if you have like a prior research experience. So that is why undergoing research is very, very, very important for an undergrad, especially if you want to go for grad school after your undergraduate degree. Third point is because I mean, it helps transform your curiosity into problem solving. I don't know if you're like me, that I just like to think and say, oh wow, I mean, say for example, yesterday I saw a particular bus. The bus was driving at a very fast speed, and suddenly the bus just suddenly jerked forward like at a very sharp rate. And so someone like me, I can just say, wow, what happened? How was that bus, like what happened to the bus? Was there some kind of traction between the wheel and the road? Is the road too smooth? Like, is the tire like kind of bad? Is the friction not enough? Just get to ask yourself that question. You are being curious, right? And so doing your research, getting your studies right, just helps to answer that question. And so that's again why research is very important, because we have questions and we need answers to. So moving on. Now, this is the journey to, doing your research and reporting your findings in, you know, a journal or a conference, right? So first of all, it begins with curiosity. You have to begin with a curiosity. I'm going to explain all of this in our following slide, and we're going to see how you can, get into it. So now you need to be curious. What do I mean by curious? You need to think, like I explained earlier, is there a particular is there particular something maybe in your bed, in your classroom, maybe when we were watching a particular video on YouTube or TikTok or Instagram, was there something that just intrigued you, that you asked yourself, how is it possible? How was it able to happen? How is that robot able to move? How is the plane able to fly? How can you convert plastic to diesel or kerosene? How can you extract hydrogen from water? You just have to, that curiosity, that's the first stage to doing research. You need to ask the right questions. You need to be curious, and then you need to ask the right question. Which takes me to my second point, the question phase. The question phase. Like I said, for curiosity, you think back and said, this guy just converted plastic to petrol or diesel, right? Then you say, how were they able to do that, right? That's the curiosity that led to the question. You notice something and now you are questioning it. The third one is the method. You think about it. Okay, say I want to reproduce what these guys have done. Say, for example, Silas and Sylvester, they were done that did the project converting plastic to diesel, right? For example, and then you have to, like I say, how can I, do something that they have done? Maybe in a more, maybe in a cheaper way, or like maybe in a more advanced way. Just basically, you just want to see for yourself if truthfully you can convert plastic to diesel, right? And so you think about, okay, the method. What exactly did they do? How did they do it? Like, what did they put in place to do that? Like, what procedures were met? What steps did they follow, right? And that's the method, right? And so the data basically, I mean, it might sound like data, but I don't mean like numerical data. It can be numerical data, but this data part is where you start gathering data. Okay, for the plastic has to be a PET bottle, maybe a Coca-Cola bottle or a Pepsi bottle, and then from nowhere, I mean, the temperature, plastic bottle melts at 250 degrees Celsius, then it must be at a pressure of 2 kilopascal, and of course the material for the reactor that will burn the plastic must be made of steel. That is the data phase. That is the place where you must get your facts right. Now please don't mix it up. The method is where you ask yourself the step-by-step approach to get to your answer, right? The data is you start fixing values, you start fixing numbers, you start assigning parameters to those things, right? So you ask yourself that question, right? For PET bottle, if I want to convert plastic to PET, of course, it needs to melt. What is the melting point of that plastic before it turns into gas, before it turns into petrol or diesel or whatever the case may be? That is the data phase. You ask yourself, okay, which kind of which kind of material should my reactor, because of course it needs to go through a particular heating chamber, which is called the reactor, before it turns into gas, right? So you ask yourself that question: what material, right? Should it be steel? Should it be titanium? Should it be silver? I mean, I'm just giving an example, please. Yeah. So you ask yourself that question. The next is analysis, right? So analysis also based off the data you have gotten, then you actually do the experiment, right? You build your system, you build the react. In our case, because I'm giving an example of converting plastic to diesel or petrol, you ask yourself that question, then you build the system. Okay, there's going to be a reactor here. The reactor, it passes down to the condenser. The condenser has water or a coolant in it. That coolant is going to cool the hot gas coming from the reactor or the heater. It cools it to water. So that is the place where you do your experiment or your research, right? Now, of course, because I'm giving an example, research does not have to be like you are building something, right? It can be in form of anything. We'll get to that in the following slide. I just want to tell you now that it doesn't have to be like you don't have to build stuff. You don't have to say you are building a robot or an aeroplane or I don't know, a pyrolyzer or what the case may be. It can come in any form, and I'll explain that later. Now, it is after you have done your research, you get your data, like you get your result. Okay, this plastic melted at 50 degrees Celsius, and this is the quality of petrol that we got. It is after you have done that experiment, you now communicate. Now, communicating is that point where you need to write. You need to, of course, communication means what? Telling people, right? So you need to write it out. And that is the part where I think most people really want to know, but like they don't exactly bother about the first five. No, the first five are very important because, of course, you need to do a particular project, you need to do a particular research before you are able to write. Like, because, of course, you cannot pour from an empty cup. Because what do you mean by you want to write? What do you want to write on if you've not done a particular project or like you don't have like any direction towards what you want to write, right? So you need to write, you need to like you need to work on something before you say you want to write. Because of, I mean, say for example, you want to write a paper now, there's going to be the case of introduction, literature review, methodology, results, right? In your result aspect, what do you want to put there if you've not done an experiment before? That is why these five steps are very, very important. Then you communicate. I'm going to talk more about that, of course, in following slides. I just want to put it out there right now that, of course, you must first do a project, a research work before you write, before you communicate, before you put it in a paper for presentation at a conference or for publication in a journal. Now, after writing, of course, you can have new curiosity. For example, you might say, for our pyrolyzer system, our plastic melted and turned to petrol or diesel at 250 degrees Celsius. What can I do to make that plastic burn at 100 degrees Celsius? Can I put a catalyst there? What will be the effect of adding a catalyst to the plastic bottle for it to be able to melt and turn to petrol at 100 degrees Celsius? That is the point of new curiosity. That is what they call new curiosity, because of course it is after you have done a particular research, after you've done a particular project, you get to ask yourself more questions. Okay, we took this route. What if we are taking the other route? What would have happened? You start to ask a new question, then you go back to step one again: curiosity, question, method. So you can see it's in a loop kind of thing, and it's very important because, of course, when you do research, you don't just stop there. Science evolves every day. In fact, science evolves every second. So when you work on a particular project, you don't want to stop there. You want to ask yourself the question of what next. If plastic melted at 250 degrees Celsius today, if we add a catalyst, right, what will be the new temperature at which plastic will melt out? You get to ask yourself those questions. It is very important that you have new curiosity. Like, it's very, very important. I've taken much time on this. Let's move to the next slide. Please, can you hear me and can you confirm if I'm making sense to you people, please? I actually appreciate feedback. Yeah, thank you very much. Thank you very much. Thank you very much. Now, moving to the next slide. Yeah. Now, the abstract, the rights, and the real. I won't be doing that now. I'm going to jump to the next thing, which is identifying research gaps. But thank you very much. Yeah. But before we go into identifying research gaps, we are going to go back to curiosity and questions, right? Now, like I said, it's going to be very, very interactive. I need you guys' feedback because, I mean, it just makes more sense. If you guys want to, then you need to, put your hands like to work, right? So I need to ask yourself something, right? What is a particular area that you are willing, like that you want to, like, publish on? Say, for example, the SP, STSC, or the NAISH, right? I mean, if I'm not wrong, the call for paper has started, right? What is that particular thing? Maybe a particular question, a particular project that you want to work on. Like, is there anything you have noticed in the field of energy or petroleum or whatever that, like it's just intriguing to you, right? And can you tell us about it? So I'm going to open the floor out to anybody. Like, I just need one person to talk and tell me, is there anything that you are willing to like write on for STSC or NICE, and we can go from there. So anybody? Remember, I said there's a giveaway, so now I need you guys come in. Okay, I see Janet Fraser and very demure that you can speak, Janet.
Good evening. Good
Good
evening.
evening.
Thank you so much for your session. I'm really enjoying the session. I'm currently drafting my LinkedIn post.
Okay.
So basically, I had an idea during one of our lectures. That's polymer process engineering. So
Okay.
basically, we're talking about waste and how they can be converted to energy. So I planned on writing a research paper on waste to energy using incineration.
Good. Now, keyword there, waste to energy through incineration. Thank you very much. You can unmute yourself. I'm going to now, let's look at what she has said, right? She wants to work on a project that deals with taking waste to energy through the process of incineration, right? Now, how do you get there? How do you get there? Now, you already have your idea, right? You have your idea, but you don't exactly know your questions, your method, your data. No, you are at your curiosity stage, which is very, very good, very genuine, very mindful. You are in your curiosity stage now. You need to go to your question, then your method all the way through. Now, how do you walk yourself through that? Right now, this is what we are going to do. Now, you need to get familiar with what is currently happening in the field of waste to energy, right? You need to know what is currently happening, like what is currently happening, what is the state of the art. Oh, as did someone do something last year? He worked, maybe he worked on waste to energy, and maybe through that same incineration, but maybe like he used maybe plantain peels, right? Maybe someone else did his own, and maybe he used plastic bottles, like I said. Maybe someone else his own. Maybe he used just any organic material, right? But I think you're in chemical, since you are doing polymer, right? So maybe you are doing something related to chemical engineering, or maybe a little bit of mechanical, I don't know, but mostly chemical, right? So, right, you need to ask, great, exactly. You need to ask that question. Now, how do we go from what you said into actually knowing what has been happening in your field? Now, you need to know what is called a keyword or key phrases. Now, keywords or key phrases are clauses or phrases that you will use in getting prior research in that field. If, for example, you are working, you said you want to do something on waste to energy through incineration, right? That exactly is some kind of keyword or a key phrase. I mean, it's a bunch of words, so it's a key phrase, right? So you need to go to a particular database and check what is currently happening there in the niche of waste to energy through incineration. One way to do that is by going to Google Scholar, right? Google Scholar, and I will employ everyone to just go there so that, I mean, like I said, it's going to be like an Amazon session. So we're going to go to Google Scholar. I have my Google Scholar here. Can you confirm if you can see my Google Scholar? Oh my God. Let me see if I can share another screen. Okay, yeah, let me present something else. So can you confirm if you can see my Google Scholar now?
Yes, we can.
Okay, great. Now you want to go to Google Scholar, right? That's the first thing that, I mean, that's one of the places you can get like recent works on. So you go to Google Scholar, you type, okay, waste to energy, right? Let's start with that. Well, okay, I mean, it already brought out a couple of things for you: technologies, incineration plants. I mean, so let's just go straight to incineration because I mean it's very obvious at this point. But I mean, in some cases, it's not always easy, right? In some cases, it cannot be this easy. For example, in my project, my final year projects, I worked on a Delta robot for 3D printing. Like, it was, oh my God, I had to be looking, using different keywords, different key phrases before I could get exactly what I was looking for, right? So you want to go to Google Scholar, type out your keyword. If you're working on, if you want to work on maybe a robot for mental illness, just type it there. Just type it there. Maybe robotics for mental can you see mental health. So basically, this place is a very useful tool for you. You can find different things there. So let's not delve too much. Let's go back to waste to wealth through incineration, like she said. So now you're going to look through everything you have. Now look at this. You can see this. You can see this. There is this one is anytime. That just means papers that have been published like anytime. Like you just want to see any paper in that line, right? So you go to anytime. If that you want to look at papers only published in this year 2025, you just go there. Please confirm if you can see my tab. You go there, you click since 2025. You can start the tab has changed. Great, thank you, Glory, thank you, Glory. You can start the tab has changed, right? So you are going to, if it's that you want to look for papers maybe in 2024, you go back there, click since 2024, and it will give it out for you. If you want to maybe a custom maybe between 2020 to 2025, that one's a big deal. You go to custom range, you type your stuff there, 2021 to 2025, and then you click work, search, and it basically gives you paper between those range of 5 years, 2021 to 2025, right? Now that of 4 years rather, excuse me. So for the sake of this, let's just click anytime, right? You can just go to maybe, oh no, let's do 2025 rather, because it's this year, so we need to be like maybe recent. So we just go to maybe anyone that just look through. You don't have to open it, but just look through. Check the paper titles. If anyone if anyone like sounds demure to you, you can check it out, right? You can check it out, no problem with that. So let's see. Let's see. Okay, no, this is no, we don't want to use this. No. Okay, so let's just move to the next page. Let's move to the next page. Okay. Oh, this is not available yet. So again, like I said, I mean, it's a research. So of course, you're going to do a lot of search, search, and then if you don't find it, you research. Miss have don't drop keyword like that for you people. So I mean, you have to search, and it could be that the key phrase is not doing justice, right? So Eniola and Janet Eniola, do you know what particular wastes like you want to study? Like, do you have any idea of what you think the waste can be?
So plastic.
Plastic, okay. So let's just change that to plastic. Make our work easier. Plastic to energy. True. Okay, so let's check this one out. So you open the paper. So please confirm that you can see my screen. Okay, it's loading. I think okay, yeah, it's here, right? It's here. Great. So you want to see, basically, you want to understand what the person has done, so that you can say, okay, what can I do in my own line, right? So you go there. Yes. Now this is where literature review comes into play. Now let me go to literature review. Right now, literature review, this is where it comes into play. Now, when you're doing literature review, you don't have time to read all the papers. Like, you don't have time, because you're going to, again, please don't check, you can't only check one paper, you have to check series of papers, maybe like 5 or 6 or even more, so that you can basically understand what like you want to do. So it's because we are trying to save time. Let's just stick to one and let's see if they did something that made sense, right? So First of all, just read the abstract. If the abstract sounds like something you want to do, right, then you can continue, you can proceed to read the rest. If from the abstract it's sounding like nah, this doesn't exactly align with me, then you move to another paper straight up. The abstract is supposed to the abstract is supposed to tell you like details about what they did in their work. So if the abstract is, can you show? Okay, I'll remind me after this, after the paper stuff, I'll show you. Thank you. Yeah. So abstract, like the abstract needs to be very, very detailed. If on the abstract you cannot exactly get what the project is about, then just move on. And that is the reason why some people's paper gets rejected. Say, for example, they submit an abstract to a conference, right? It gets rejected because your abstract is not doing justice. It's just vague. You don't want to do that. Your abstract is supposed to be very, very detailed. Let me tell you something. Your abstract is like a condensed version of your introduction, your literature review, and your results. And I kid you not. So if your abstract is not at least talking about your introduction, the review, and then your results, then that's not an abstract. I'm sorry. No, your abstract is a condensed, maybe 250 words. I think I've seen 400. I've seen 400. But basically, depends on the journal or conference. They'll give you a word limit. You must do justice to it. Your introduction, your method, and then your results. Like take it in a condensed form. Now let's go back to the paper. Now, of course, we don't have time to be reading through, so we're just going to assume that the paper relates to what Janet Eniola wants to do. Let's just assume, right? So now, then after you've confirmed that the paper sounds very demure to you, you can now proceed and just skim through. Again, you don't have time to read the whole paper. Please, you don't have that time. You don't have that time, right? Just use your eyes and skim through what you are looking for, right? Now, in this case, let's just go straight into what the paper did. Now, that's why I said we should skim through. Now, look at this. Let's scroll down to see if they said anything about what the paper did. Again, I'm skimming through. We are still skimming through. Good. Okay, now look at what they said here. This is what we are interested in. They said, therefore, the innovative aspect of this article consists. Okay, I think we need to read it previous paragraphs. But basically, you get the point. Just look for that place. Just look for that place in the introduction where the authors say what their paper is addressing. Now, let's just continue. Let's see from here. They say, therefore, the innovative aspect of this article consists of a developed model which allows the prediction of characteristics of thermal process costs for polyamide, coal fuels, biomass waste, fly ashes, and their mixture. You read all of this, right? It's from there that you used to know what the authors did. Again, you don't have time to read the whole paper. You can't, if you don't read it, it's your time. But I'm telling you, you don't, if you are doing the theory review, you just need a snippet of the introduction and then you go straight to the results. Now, if the results section made sense and you want to reproduce, or you want to do something similar, then you can now go and check the methods that they did to get there. Now, let's go and check their method, their results rather. This paper is quite lengthy though. So allow. I can't see the results here. I can't see the result. Don't worry, I'm still going to explain how writing works, but we need to understand basically how to do research first. Okay, this is result here. So you just want to understand, okay, the test result shows that there is an increase in the content of coal and coal sludge. I mean, I don't have time to read all of this, but basically, if you are doing a review, if you are doing a history review, you want to start from the abstract, then you read a snippet of the introduction. If the work is making sense to you, go straight to check the result out. And if, say for example, the paper, let's say for this paper now, maybe they used plastic, maybe they converted plastic to diesel or petrol using, of course, the method of incineration, right? Janet Eniola might want to use, what's it called, plantain or banana peels to say, okay, I want to convert banana peels to petrol or diesel through the method of incineration. And then she can also, okay, I'm still going to follow these people's procedure. She will still follow their procedure, but instead of using plastic, let us try banana peel. Let us even see the result that will like, come out of it. And that is exactly what they mean by curiosity. I mean, you are asking now, okay, these guys used plastic, right? If I use banana peel or I don't know, any other organic matter, what will be the outcome? What should be the results, right? And one way you can even like be able to decipher like new research direction is by going to the conclusion or the discussion. In the conclusion of discussion, they might say something like the future work of the project. Maybe they are proposing to use another type of organic material. So basically, you might want to check out the conclusion if the authors mentioned that, but from here, I don't think the authors mentioned that. So which is fine. I mean, it's not compulsory to that, but some papers, the authors stated, okay, the for possible future works, you can use plastic, sorry, you can use banana peels, you can use silicone or whatever organic material. You get. So that is how you get to do literature review, and it's from this review that you get to understand what is currently happening in that field or in that line of work. Right now, let me just for the person that said I should show how I was able to, do a custom range. So look at this. You can see custom range. Yeah, look, can you see that custom range? Right. Confirm that you can see my screen, please. Yeah. Okay. Now you click the custom range and then you type here from year what 2020 to year what 2025, right? And then you click what search, and you can see the tab has changed. So all the papers that you have here, everything I have to show you will be papers from 2020 to 2025, and you can iterate on that. You get. So that's that about that. So that is how you get to understand what is happening in your field of study, right? Now it is now after that, it's now after you understood, okay, if these people did this, what can I do? Okay, is it time that you ask yourself, Janet, Eniela, you ask yourself, okay, these guys did this. They converted plastic to petrol through the process of incineration. Can I convert using the same method that they use? I don't know. Or you can, of course, you can formulate your own method, please. You can formulate your own method. You can say, okay, well, if I use banana peel or plantain peel or I don't know, bean shaft or whatever organic material, I want to understand like the outcome, the process of that and what the result would be. Like that's now you are thinking like a researcher. Of course, it's still quite basic and it's still quite basic because if you want to do something more advanced, you can start saying something like if we want to add IoTs, that now this for those in mechanical and electrical computer now. If you want to add things like embedded systems, maybe to tell you the temperature of the heating chamber or the temperature of the condenser or the level of water in the condenser. Of course, now you're getting into something more technical. But of course, you can do this because of course you are an undergrad and I'm assuming you don't have maybe skills elsewhere, right? But again, that is the importance of collaboration. You need to collaborate with people in your your friends, maybe your seniors that know about more technical, maybe machine learning or um, um, embedded systems and all of that, right? But I mean, you can do that. You can say, okay, I want to just do my own simple pyrolyzer, my own simple incineration method of converting banana peels to petrol, right? And that is that about that. Now, it is after you've done that, of course, you research on the methods. You research on the methods, right? You ask yourself, okay, the methods, what can I do? How do I go about this? Now, again, that's also research. Research is a very like it's going to stress you. It's going to stress you basically. So you need to ask yourself, okay, how can I go about the whole project, right? Then you do your experiment, you do your whatever you want to do, and then you get your results, then you now start writing, right? And that is in simple, because I mean, we are working with time. I don't want to go deep into all of these things, but of course, I'm going to cover as much as I can in this slide. So, Janet, I hope I've been able to like let you understand a bit how you can go about your work. Now, Say for example again, before I proceed to the next slide, say for example again, you don't exactly want to build something. Maybe you just want to do a review paper. Maybe you want to write a review, maybe like a review paper for maybe NICE or whatever conference or whatever you are looking at. You can do a review paper. Now, a review paper, a review paper is a paper that does a literature review of works that have been done in that line. Say, for example, you said you are interested in waste to energy through incineration. You're going to write like a paper that that in a way summarizes everything that has been done in that field, maybe for the past 5 years, 10 years, 2 years. It depends on you. So you might want to put that down, Janet. You can say, okay, well, instead of doing an actual experiment, you want to write a review paper. You want to do a review work. Of course, now this is paper writing. We'll get to that later in the slides. But for now, just for doing research, this is the way to go about it. You do your literature review. You ask yourself the questions. How can I replicate this? Now, okay, no, I will say it later. Don't let me say it now. So just to confirm, can you guys hear me? Am I still on track, please? I like feedbacks, please.
Yes, yes, we can, and you are
Okay,
definitely still on track.
okay, great, great. So let me go back to my slides and let's continue the discussion. A second, a second, a second, a second. Oh my God, it's taking time. Oh shit. Let me just stop sharing. Okay, let me share again. Share. Please confirm that you can see my screen. Thanks, my okay, great, thank you. So I've talked about literature review, which that's what we did right now. So again, we used Google Scholar, right? It's not only Google Scholar that you can use to get paper from. You can actually go into there's what they call Elsevier. So, but although Elsevier, you need kind of like an access for it. I actually have an access, but I mean that's because I'm working with some. I have it's long story, but I have a particular kind of stuff going on that makes me able to access Elsevier paper. So I'm just put that out there, right? But I mean, but with just Google Scholar, you'll be fine. Trust me. Google Scholar is like it's Google, and Google has a lot of data. So Google Scholar alone does the work for you. So let's just move on. Now, of course, now the curiosity to question. This is the formula. You ask yourself what fascinates you. Now, for example, me, for example, now, no, don't let me use myself. It's going to be international. Let me use Janet Enela for our case study now. She said she's interested to know how you are able to convert organic materials to petrol or diesel or gas or whatever articles may be. Now, you ask yourself, for me to be able to get my research question, what's that particular topic that I'm looking at? And for Janet's case, she said waste to energy through incineration. That's our topic, right? That's our topic. Now, what is the focus? Now, please, focus and topic are not the same thing. The topic that she wants to look at is what I've mentioned before, waste to energy through incineration. Now, what is the focus? Now, because that field is broad, waste to energy incineration is broad. I mean, she's a chemical student, like she said, a chemical engineering student or a process engineering student, right? So instead of like maybe her focus is the actual chemical reaction, like what exactly is the chemical reaction happening that plastic is able to break down to give petrol. That might be our focus. Now that is what focus. Please don't confuse focus with topic. The focus is that specific thing that you're looking at. For Janet now, she said the topic is what? Waste to energy to incineration now. Now, Janet's focus might be on, I want to know that chemical reaction. What exactly is making plastic to break down? For Sylvester's own might be, okay, no, instead of the chemical reaction, I want to understand, what if, I'm sorry, what am I saying? No. Sylvester might want to say, okay, instead of like understanding the chemical reaction part, I want to understand the material part. Say, for example, I said, of course, say, for example, you want to build a particular system now, right? The reactor will be made with a particular metal, maybe steel or titanium or aluminum, right? So you get, so person might say, okay, instead of chemical reaction, I want to understand the effect that material plays in the in the reaction in the experiment, right? And you just like basically they are different focus, but it's still what? It's still research. Then you ask yourself, what is the purpose? That's that's when you ask yourself, why am I doing this? For Janet now, I'm giving example. Janet said she wants to like focus on the chemical reaction of how plastic breaks down to petrol or diesel. Now, what is the purpose? Now, I can't answer that for you. You are the one going to answer that for yourself. For each of you, you are going to be the one to answer that by yourself, not me. But I'm just putting it out there. Is after all of this, you'll not be able to now say, okay, now that is my research question. Now, that is what I want to do. That's what I want to study. That's what I want to write on. Let's move on. Now, okay, yeah, good. Now, after you have, figured out what you want to do, like now, you now go into the methods, right? Now, like I mentioned earlier that you don't exactly need to build something, right? You can do basically anything simple, like it can be coding, like it can be simulation. Maybe you're working on SolidWorks or ANSYS or HYSYS. I don't know what those chemical guys call it, or you want to use, I don't know, Proteus or I don't know, different softwares, right? It can be modeling again, SolidWorks and all of that. So you don't exactly have to build. I mean, we are students, you don't have money to be saying you are working on to build a robot or a car or something like that. You can just do something computational, which is cheaper, like which like you get it. Do you get the for now you are undergraduate. The point is not to like impress like people like experts. Your job is not like, of course, you want to impress them, but if you guys are starting out, so just do something that is within your power, right? So you can just say, okay, no, let me look for something on simulation. Okay, can we simulate plastic to waste on ANSYS or on whatever? That's your, of course, I'm giving an example. In some cases, it might not be possible. In some cases, it's possible, but that is your duty to find out. Maybe, okay, let's delve away from plastic to waste. Let's deal with something else. Say, for example, maybe aeroplane now, right? Maybe you want to understand the effect of drag. Okay, so for those that are not in maybe mechanical or aerospace, I'll upload this for the thing that I'm using right now. So maybe, for example, maybe you have an aeroplane, right? You want to understand the effect of fluid, maybe air, right? The importance of air around aeroplane. You don't exactly need to build maybe a prototype. You can just design something on SolidWorks, just draw something on maybe a card design, right? And then you take that card design and simulate. Now, simulate is like, okay, you subject that your model into different forces, right? Maybe drag force, lift force, aerodynamic coefficient, all those jargons, mechanical jargons you get. So again, you don't exactly have to build something. You can, like I said, because you are starting out and you don't have the equipment, you don't have the money. If you have the money, you can build a aeroplane. Now, the now will concern you, but for people like me and my own colleagues, we just stick to what we can do. And so you want to do something on programming, something on simulation, something on modeling, and you'll be fine, depending on what the conference requires of you. Then, of course, the experiments you can do, like, of course, real life test, where in Janet's case, you might say you want to build an actual pyrolysis system, convert plastic or carbon materials to petrol. And of course, it can be hybrid. You can say, for example, let me talk about waste energy. Let's talk about maybe robots and robotic arm, right? You can do like an hybrid approach. Say in step one, you model a robotic arm and then subject it to some forces on by simulation, right? You understand the mechanics behind that, right? You record your values. Now you build that robotic arm, you subject that robotic arm to similar forces. You record your results. Now you're going to do some kind of validation. Is your computational approach matching your actual real life testing, right? So again, you can do either computation, you can do like real life experiment, and then you can do both. Like you can what's it called? You can corroborate your experiment. Like you see if your computation is matching your physical model, and then that I mean it's you. So do you. Let's move on. Okay, no, I think I've missed something. Let me go back to okay, so methods, yeah. So data, of course, data, you get to understand what do I need to do to get this research done, and then the analysis is like, I mean, um, do the study, do the experiment, do the simulation, write the codes, run the codes, check your result out, and then that's I don't need to talk much on that because it's a no-brainer. And then you communicate. So let's proceed to communication. Yeah, and that's what we call writing like a researcher, which is now the one of the part that's very important because let me tell you something. As we're all scientists, right? As scientists, I kid you not. Yes, you will need to know how to do some coding or some hands-on laboratory work, some Proteus, some simulation tools, but your writing is like one of the most important things because you are going to be writing for people to read. So you need to know how to put it out there, right? And that is what this will address, right? So now before we proceed, sorry, let me see if I've not missed anything so that I know I'm just going to talk on. Okay, yeah, we're right on track. Right on track. So now the first thing I'm going to say is there are basically two places you can submit your results to. That's after doing your research, after doing your if you're doing a review paper now, right? After doing your maybe your experiment or whatever, and you want to maybe submit your findings, you can do it in two places: a conference or a journal. Now, a conference is of course a gathering of people in that particular field, or at least something similar to that field, right? And then, of course, you will see people, professors will be there, people that work in like industry will be there, government staff will be there. Basically, a conference a conference is a meeting ground for people of different backgrounds, right? Now, for journal, a journal is more like is like a magazine. Let me use the word magazine. Please don't quote me. I'm just so I can understand what it is. So we can call journal a magazine, but of course, a technical magazine. You submit your research there, and then they of course they do a peer review. Like that means they share it with people with experts in your field, and then from there you get it published if it's accepted, right? So now let's get right into write how you can write your stuff. Now how do I start? Because this part is very, 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 very important. Now, okay, let me just start anyways. As Nigerians, or actually, I think it's because of we are mostly undergraduate. That's why we do it. But you know, say for example, there is a call. Why is Glory laughing? Say for example, there is a call for abstract, right? Maybe a particular conference is calling for like papers. Now, we as undergraduates or like anybody, we just jump to write the abstract and submit. Normally it should not be so. Normally, you are meant to do your research first. You're meant to do your project first, your review or your whatever you are doing. You're supposed to do it first before you're showing now write an abstract based on what you have done, right? But of course, it is still fine if you write an abstract for something you have not done. It's fine. It's fine. But on a normal occasion, like you're supposed to actually do your work first before you write your abstract. Because if you remember what I said earlier, I said your abstract is supposed to be a condensed version of what your project, like your results, your methods, everything in one. Now, if you've not done the project, so how exactly do you want to write an abstract? Like, do you get my point? Of course, there are ways to do it, and I'm going to tell you like in coming slides. But like normally, we're supposed to do the work first. Now, before I proceed, I would like to give you like a rundown of the different kind of papers that we have. Now, there is the normal scientific or technical paper. That is, you do a particular research work, you do a project, maybe waste to energy, like Janet said, or maybe aerodynamics for drones, or maybe IoTs. Basically, you do any projects, and then you document your work. That is a normal technical paper. Now, aside that, there's what they call a review paper. Like I mentioned before, a review paper is you're not doing anything technical, like you're not going to do the coding. Of course, they don't get me wrong. You might say you want to add extra data to the review, but normally a review is just look at a series of papers, maybe 50 papers, 100 papers, 20 papers, review everything, and then write a breakdown of what you have read, right? You tell them, okay, for the past 5 years, this is what is going on in this field. right? That is a review paper. You guys might want to read up on that later. I mean, because we don't have time. So just read up on review paper, technical paper. Of course, there are other types of paper, but everything just sums up to this too. There are other types like I can't remember. I'm so sorry, but you can read up on that later, so that we can cover grounds. So I'm sure you guys have questions. Now, of course, so to write whether a technical paper or a review paper. Now, let's get into that. Now, depending on the journal or the conference, but you might want to structure it this way. Your introduction is first, your methods, your results, and then your discussion, right? And of course, conclusion and references too, but like basically these four are like the hot parts. Now, some papers and some journals or some conferences have their specific, like maybe extra jara, but basically it is always in this format. Now, your introduction is like always like introduction should cover the introduction and your literature review. Because of course you are writing, you want to, of course, address what has been done in the past. So it is your introduction that you use to you talk about, of course, you introduce the field. When I mean introduce, I don't mean you should be writing story that they not hold water. For example, in the case of Jane Eniola now, she's working on waste to energy now, for example. Of course, you don't have to be defining waste is a dirty material. Energy is you don't need to do all of that. That's just stupid. I mean, you get but when they mean introduce, that means just just what's it called? Just give just give a kind of idea of what is currently happening in that field. Now, it's not exactly a review. Like, how do I explain this? Okay, you know what? Let me show you a paper I'm currently working on so we can use that to understand better. So let me open my paper a second. Yeah, got it. So I'm going to change my screen again now so you can see what I'm talking about. Present something else. Window and yeah, session formed. Great. So please confirm if you can see my screen. Can you see my screen, guys? Okay, yep, great. So now we are working on the physics informed whatever. Now, you can see the introduction. We didn't define CNG is the type of gas that is made from chemical. No, we just went straight to compressed natural gas has emerged as the most valuable alternatives for combustion chemical. Like there is nothing like you are defining them. That's just, I mean, of course, they are not babies. They know what CNG is. They know what internal combustion engine is. So you don't have to define those crap for them. Do you get? And then of course you reference. Like let's say for example, this one now. Maybe I read it from a particular article, maybe a website, a paper, a whatever. You want to reference that there, right? And then you make sense out of it. Okay, now let's go together. They said CNG produces lower emission of CO2 and NOx and particulate matter compared to gasoline and diesel. And then you now go on. Study shows that CNG can reduce CO2 emissions by up to 22.1%. Now, that is a review, right? You are reviewing what someone has done because they said what studies show. Studies is showing. So that means now again, your introduction is actually a mix-up of the introduction to the field and a review. So let's not dwell much on all of this. Let's just just skim through. This paper, I did a lot of justice because I mean it took me a while to write this. So now this is a review. Now, depending on you, you might want to just do your review in a paragraph format, in a paragraph like maybe in a paragraph like this. But for me, I felt I think I prefer if my review is in this format, like in a tabular format, where I'll tell them, okay, the references, maybe someone that did the work before, and then what his result was and what they write. So basically, I did this. This is the reference of the paper. Now, in the particular paper, they use the SVR model. What did they do? Their input was engine speed, load, and whatever. What was their output? Their output was ISFC and emission. What was their performance? Their R square is, again, please, this is just those for those that understand ML and AI and stuff. So just in case but the point is that you just want to pick out those key things in whatever you are reviewing. Oh, last in 2024, Janet Eniola, in reference one, she used petrol. What am I saying? No, she used plastic, right? and then she converted plastic to petrol or diesel, right? Now it's from there you say, okay, well, what did she do? The input, of course, again, it doesn't have to be all of this. It doesn't have to be input, output. No, it can be anything, please. It can be anything. This is just for my own paper because I mean it makes sense for my own paper, right? For Eniola, it can be okay. Well, what did she do? Converted um plastic to diesel, right? Sylvester, what did he do? Converted banana peel to petrol. Silas, what did he do? Converted plantain peel now to petrol. Fourth one, Glory, what did Glory do? She converted her fingernails. Fingernails is organic, so she burns her fingernails and saying she converted to petrol. Of course, that cannot work. I'm just trying to give an example again because just so you can understand what I mean. And then their results. If maybe their result, okay, said their own plastic burn, their plastic melted at 40 degrees Celsius. At 40 degrees Celsius, you put it there. For Silas, his own was what? 120 degrees Celsius, put it there. And Glory, our own was 500 degrees Celsius, put it there. You get, it's just so that your work looks very neat. And so you have all of that. You have all of that. I did a lot of them. Of course, again, it's not like as if I did all of them. There are some that I just went to a particular review paper and I just did like a copy and paste. But again, I didn't copy and paste though. I referenced them. That is why referencing is important, because if you copy and paste without referencing, that is plagiarism, and that's a crime in academics. So again, it wasn't all of them. I just did copy and paste, but basically you get my points. Then after then we wrote the method. Okay, let's ignore that since we'll get back to that later. So let me share my screen. Sorry that I'm just going back and forth. I'm so sorry about that. And yeah. Yeah, share. Yep. So you have your introduction, which we discussed now, right? Then you go to your methods. Now, oh my God, I think I'll have to go back to that. My bad. I'm so sorry, guys. I'm so sorry. Let's go back to where we're coming from. Oh my God. Okay. Now, the methods. What did we do? We took a particular engine and then we wrote out their parameters, their whatever. From their parameters, of course, we did some mathematical jargon. This is the thermodynamics for those in mechanical and chemical, or I think aerospace here too, yeah. So these are the mathematical jargons. Of course, it's part of the methods because whatever you are simulating, whatever you are coding, whatever you are programming, or like doing computational stuff for, everything is backed by mathematics. So you need to put your mathematics there, like your technical jargons have to be there. So these are the equations of all the combustion rubbish, is everything. Oh my God, oh, Jesus. I'm sorry, let me just keep right here. After that, after the mathematical jargons, we now went to the design of experiments, because what did we do? We told them what we did. Oh, we did this, we did that, we did this, we did that. From there, we went to MATLAB, we did some MATLAB coding, we did this, we did that, we did this, we did that. And then you go to the pre-processing, to tell them about your AI model. You said we did ANN model, and then we are going to like compare it with SVR model. You talk about the methodology, and then you go straight to the results. So I'm going to explain it. I just want to run through this paper. So I want to go and come back. So this is the result part. That it still needs a couple more work. Of course, this paper is still a draft. We need to add diagrams and stuff to it. So, but for now, this is just a draft that I've submitted for my professor's review. So we have this, we have the results, we have some preliminary results. Again, preliminary results, because this research is iterative. You need to do and redo. Yeah, you know that what you get makes sense. You have that, and then of course you can see the references and stuff. So yeah, so that's just all of that. So let's go back to the slide so I can explain like better for you guys. Okay. So your methods are like the procedures for your research. The procedures. Then after you write the procedures, you want to write your results. You tell them what your results were. Put your graphs, put your if you maybe do something on simulation now, you put your visualization. If you did like an actual, even if you built an actual device, you put like images of maybe maybe, for example, if it's a robot, you put images of the robot there. If like if there are like data, maybe for example on the robot, maybe you did some kind of experimental test on the robot, and like you add some graphs and stuff, you put your graphs there. That's where your result is basically the most important part. Because I mean the result is what is telling the reviewers, the readers, what you did. Like the introduction is just formality. The method is formality. Not exactly formality, it's also important, but the result is exactly the part that is telling them what you did. And then you discuss. What do I mean by discuss? Of course, you want to explain to the readers what your results mean, right? Say, for example, I tell you, my performance matrix was R square greater than 0.9, just like I showed you in that paper, and you're just saying R square greater than 0.98. You'll be like, what does that mean? No, you're going to explain it. Okay, R squared greater than 0.98 means that this and that could blah 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 gibberish yada yada, those rubbish, right? That's what is happening in result and discussion. Yeah, depending on the paper, they can actually put them together. Result and discussion is always most times always together. You now have another place, conclusion, where you conclude, like you just give a one, maybe I don't know, paragraph summary of everything, and then you reference. And let's say, for example, you want to acknowledge, okay, say for example, some people helped you in your project, but like maybe they are not part of the authors, right? So you want to just acknowledge them. Maybe if anybody sponsored your work, maybe it was someone that borrowed your laptop, you want to say, oh, I acknowledge Oluwatosin Kolade for giving, for like borrowing us the laptop for us to do the coding. I acknowledge NASA for giving us the money to fund this project. That's those stuff, right? Then you now reference. Please always reference, because if you don't reference, you are doing plagiarism. Good. Now let's now look at, you can see, write your abstract last. Write your abstract last. Now I'm going to show you why like your abstract needs to be cooled if you want to submit for a conference or a journal. Now your abstract needs to be very like very well cooked. Now let me take you to a particular place, present something else, window. Yep, a second, so we can see for ourselves what I'm talking about. Yep. 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 Now, this is an example of a vague abstract. Just let's read through. This study focuses on renewable energy in Nigeria. It discusses different forms of renewable energy and advantage. This research will analyze some challenges that affect the use of renewable energy and give clinical clinical. The work will also talk about how clinical. I mean, it's just saying, it's just parambulating. It's not, I mean, it didn't give details about what the work did. Let's look at the second example. This study assesses the technical and economic feasibility of hybrid solar biomass power system as a sustainable solution for rural electrification in southwestern Nigeria. Hourly solar radiation, blah, blah, blah. Simulation results indicate that combining photovoltaic and biomass systems reduces the levelized cost of electricity by blah, 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 blah. These findings are light. Can you see, like in that abstract, they have, yeah, look at this study as like he had already given us like well detailed stuff about his work, and that is why it's always good to write your abstract last. Like it's after you have written your result and whatever, you can now say, okay, now based on what I've written, I mean that one says it's not hard. Just look through, okay, based on my result and everything, let me cook a 150 word, 200 word abstract and all. But now for cases whereby you have not done, if you've not done the, say for example for NAIS now, you just want to submit the paper for NAIS, but you've not done the actual work. How do you go about it? And that is what I'm going to address now. Now again, you want to think. What do I want to write about for NAIS? What research do I want to do? Do you want to do a technical paper or a review paper? Right? What do I want to work on? And then, because of course you've not done the work, but of course you need to do a particular review, like you just want to check what has been done before, right? So that you can understand what is expected of you, right? Because of course, you cannot pour from an empty cup. Again, that in fact, I love using that statement. You cannot pour from an empty cup. You want to understand. You want to know for yourself. For people that have done it before, what was their stuff looking like, right? So that will inform you of what you want to write about, right? Now, you can draft it this way. Of course, you first start with maybe a one sentence introduction, and then you go into what your work will achieve. Now, this is the problem. Don't use stuff like this work, this paper hopes to, this work, like saying things that point to like future. No, you want to say it like this work, this paper is addressing this. You don't say it hopes to you don't say things like do you guys get my point? Don't use words that is pointing to the fact that your paper has not your work has not been done. Like you can say that is after like the old thing that you know. You want to actually be affirmative. This paper, this work is dealing with this and that and everything, blah 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 blah. Don't be using words like we hope to do this in this paper. Now, trust me, I've seen that before. You don't want to do that. No, you are going to be affirmative. Say that no, this work is addressing this and that, and then you continue. You will say you just give some kind of idea towards your work. Like for example, maybe if it's a review paper, right? You want to say previous studies have shown that this and that and this and that, right? This work kind of like does a recap of everything that has been done in the field of this, and then you just put in some, like you just fix in some key things that would inform the reviewers that this guy has actually done something. Like it's not like as if he's projecting to do. I think he has done something, so you can accept this paper because you don't want a situation whereby like your reviewer is like, look at this one. She doesn't think he wants to scam us. What will you never do? You don't the right, you don't the clinic on. No, you want to cook that thing very well that would sell as something that you have already done. Please, this is very important for those that want to move over to maybe not nice, maybe other conferences, right? This like you need to do that. Don't use words like it's a few. Don't say things that point to the fact that it's a future work. Do you get? Let's move on. I think we're almost done. Now, these are the ethics in research. Of course, like I said, always cite your paper properly, always cite works properly, avoid plagiarism. You can use things like Turnitin or Grammarly to just check out your work if it is good, and then be honest about your data and results. Please, that honest is very important. I kid you not. You can publish a paper and then in like next year, they will contact you and said, no, this your work is falsified data, and then they retract. You can go to Google right now and search. A couple of papers this year have been retracted. One of my retract is that it was published before, but then the reviewers or people found out that that paper was actually based on falsified data, and then they retract it. That means you have wasted time. You have wasted. In fact, your own personal integrity safe will be at stake because nobody will want to work with someone that is manipulating results. So please be honest about your data. Be honest about your data. Very, very important. Then next, okay, case study. Yeah. Now, case study is when I said I want to, but of course, we already used Eniola as an example. So I'm going to call on just one more person before we could go to our question and answer. Just one more person. I think I saw Jesu Tony, his hand was raised earlier. I want to confirm if you wanted to give your own case study or wanted to ask a question before. So are you on the call if you've not left? Okay, is there anybody that wants to like run us through what he is thinking to submit for a particular conference or journal? Anybody? Let's be snappy so that we can meet up with time for questions. Nobody? Okay, no problem. So we have done, okay. Yeah, you can unmute and speak.
Okay, good day, everyone. So I
Okay,
have something I'm working on, even though
okay,
I'm about to start like working on something like more specifically petroleum section. But what I'm basically working on
Mm-hmm.
now is it's
Mm-hmm.
about name entity recognition. That is it's an NLP research, like natural language processing and research problem. So it's
Yeah, yeah, yeah.
about name entity recognition for
Mm-hmm.
African languages. So based on the research I've done now, I've seen like a robust data set I can use. I think about 20 different um African languages, yeah, are represented there. So what I want to do
Okay.
basically is to like
Okay.
create a framework for evaluation so that when people build their system,
Okay.
like you can use my framework to
Okay.
test against it,
Okay.
whether you
Okay.
have met a
Okay.
particular threshold or not.
Okay, okay, great. So it sounds like you are, I mean, you've done quite a couple of things. You've done your curiosity, you've done your questions, and I think you are pretty much currently in the data and the analysis and then writing part. I think those three parts is where you're currently at. So now you might want to check maybe what people have done before, because I think this project, I think like so something similar. It might not be for language, it might be for something different. There was someone that did something on like in my school. She did like a particular like email for recognizing African foods, right? Like recognize, oh, this is amala, this is semo, this is rice, whatever it is you get. So I'm sure there are people that have done something similar to for language now, maybe German and French and whatever. So you might want to like, look at it, like go through, just go through prior, like it's very important that you need to put like, just look back and read what people have done. Like it's very important to research. You just need to do your review. You just need to do your literal review, right? Then after then, of course, now for your method, do you know the kind of models? Okay, so you said natural language process, NLP. So aside that, like, do you know the nitty-gritty of like your work aside from like the whole like NLPs and coding and stuff? Do you know like do you know like the nitty-gritty? Do you know the method that you need to put in place? Do you know the mathematical backing to your NLP? Like those are things, because your report is going to have that. You can't just say you did NLP. No, you need to add some mathematical backing. Maybe if there's any kind of formula for NLP, because I know for R square, all those RMSC, there are things like that. So no, so you ask yourself that, like, you need to do your findings, right? Are there what am I saying? Like, yeah, you need to do your findings on all of that. What are the methods that I need for my research, right? Do I need to do you think any what if someone has made, maybe there's a maybe someone recently made like a new kind of ML mode, like maybe not NLP now, maybe there's something different currently happening. You might want to check it out. Like, because again, you might, of course, as an undergraduate, you can do that, but for graduate level, you don't want to be redundant. You don't want to be sticking to the past. Like, for example, imagine if in 2025 someone is still doing research. Of course, undergraduate is still fine, but when you're doing a master's and PhD, that's just crap. Imagine in 2025 someone is still doing research on, I don't know, steam turbine. Steam turbine that has been existing since 1914 or something like that. Except if the person wants to do something more modern, maybe ML for steam turbine. I'm just giving an example, right? I'm just giving an example. But you get my point. You want to be like current. But I mean, as an undergraduate, you can just do anything. I mean, because of course you are just new to the field. I mean, nobody will look at the goal is that at least you are progressing in life. Like, at least you are doing something. You don't have to bother about if it is a world class 100%. No, please, you guys should start from somewhere. Rome was not built in a day, right? So please start from somewhere, and I think you are doing a very good job. So yeah, thank you for sharing that with us. Just so Tony, you can say what if you have any like research curiosity that you think you want to work on.
Thank you, sir.
Yeah.
Okay. Actually, my question is
Okay.
about, it's not really about SPE now.
Okay.
It's about the aviation industry.
Okay.
That's where my research is focused on.
Okay.
Now, thanks to this meeting, now I was not aware of Google Scholar before, but thank you, sir, for the opportunity. Probably that will
Um,
aid my research. But
okay.
now my issue is, or my challenge is, number one, human resources.
Okay.
I was curious about probably making an innovative research in the aviation industry whereby you have flapping winged aircraft. But doing it alone, my curiosity, along that curiosity, I got tired and probably just had to suspend it. But with time, I couldn't just ignore that passion. It keeps building, but I'm still stuck at that level of human resources. I don't have all the skills needed. I need men, hands on deck. I was not like,
Okay.
I hope you will share how you were able to do it. Probably go post on your WhatsApp status that are you interested in this kind of research during your
Okay,
stuff.
okay, okay, okay. Okay, so I can see that's like a Q&A. So I'll answer that, but I just want to confirm, does anybody like have a specific kind of study? Just to Tony, I'm going to answer your question actually. Thank you for that. That will be the question I'll answer. But before then, does anybody have anything that any kind of study is looking to present to work on? Right? Maybe okay, just like Eniola said, she's thinking of working on waste to energy. Is there anybody here that is stuck, does not know what to do, like but but like ask a particular question? If there is none, you can just start answering questions and I'm fine with that. So I'll just wait for 10 seconds. If nobody raises up their hand, I will just answer Jesutono's question. Okay. Glory said she's working on multi-agent reinforcement learning for automation of multi-grade. Okay, good, good. Now, you might want to ask yourself, you might want to just go to Google Scholar, check out, of course, you need your key phrases, your keywords. In this question now, what are your keywords? Now, please you can make ChatGPT your friend, make GPT your friend. Just copy out that topic. Go to GPT, please, I need keyword, I need key phrases, like for this particular proposed topic, so I can get papers on. GPT will give you a list of key phrases and keywords. You go to Google Scholar, search it out, right? Of course, you iterate papers, iterate papers. You, of course, for some papers, you will save some of them just in case you want to use to do your writings. Because of course, when you are writing introduction, you want to reference some of them. You do that. You can go to a particular paper. Oh, they say, oh, this paper they used they used they didn't use reinforcement learning. They used something else, deep learning or whatever. Now say, oh, okay, they use deep learning. Right, I want to use reinforcement learning. Later on, I'm going to compare my results with your results, and let's just see which one gives a better approximation, a better maybe I'll just give an example, RMSC or R square or whatever that is you get. So then you need to do your review, right? And then of course you now ask yourself that question of the methods. So basically you just need to follow through with this stuff, right? Your question, your method, your data, your analysis, and all of that. So for Glory now, after you have done your findings on papers, you now ask yourself, how can I go about this? Where can I get this data set from? And because of course you need data sets for all of this. You go to Cargo, you go to GitHub, you just search, blah 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 blah. Blah. Because of course GitHub really this paper I showed you right now, we used about 20,000 data sets for us to train our model for this. So GitHub helped is it Cargo? Sorry, yeah. And just go to Google and just search it out. Bam, then data set on this and that, and you just get some things out of it, and then you save the data set. Now start asking yourself the question of this data set. How can this data set be useful to give me a result? And that, like you get, that's the data part. Of course, it's part of methods, because in your methodology you need to understand how your work, and you need to understand the workflow. So after you understand the whole and finding data sets, and you need to understand the reinforcement learning, how does it work? That's if you don't know before, but let's assume you know. You don't have to bother about how reinforcement learning work and all of that. So you start your codes, or you go to an open source model. You start, editing their codes, and just use your data set, push it into the ML model. You do this and do that. You get your data sets, look at the plot, look at the graphs. You ask yourself, does this make sense to you? Does not make sense to you? You check if your codes, if there are no error in your codes, if there are errors, you want to fix it. If there are no errors and you're sure there are no errors, you now go and write. And then after you write, you can ask, I used reinforcement learning for automation of multi-grid. you ask yourself, okay, your multi-grid, how many grid did you use? Was it 10 grid? So instead of 10, no, let me use 1,000 grid. Or do you get, just think like something that relates to you, like something extra based on what you are doing, and you'll be fine. You'll be fine. Yeah. So I hope you understand basically what you're supposed to do in your own work, Glory. Yeah. Now, for just Tony, right now, for to do a project, you need skills. Like no, you need to know like skills. Not only you, of course, you need to collaborate with people. Like, say for example, I think you study aerospace, right? Let's say you want to work on maybe you want to work on a computational project on drone. Maybe you want to work on maybe understanding the effect of drag, drag force, lift force on a drone or aerospace or a plane, right? You will need skills like CAD skills. You need to know how to design, how to draw an aeroplane in SolidWorks or CATIA or whatever tool you have. But I think SolidWorks is probably like the most preferred. And then after then, you want to yeah, you can answer after this. Tony, I will open the floor for question and answers. Now, you need skills, you need CAD skills. Like you was, I will just say this out there. As an engineer or as an engineering student, there are three things you need to know. There are three things you need to know. Now, I'm not saying you need to know them like in a master, like as a master. Like you need to like I'm not saying you need to master them, no, but at least you need to have a good idea of them. These are the three things. First of all, programming. You need to know at least how programming works, Python. You just need to understand, okay, like a Python code. What's this like syntax like? What's the compiling like just like you don't exactly need to be a master, but at least you are like sound enough to know what this code is doing. Say for example, so someone writes def init. Oh, sorry, just let me use any of those terms. But basically, when you see a MATLAB, a Python code or a MATLAB code, you should be able to understand that this I understand what this code is doing. No, you need to understand, you need to know programming skills. You need to have programming skills. You need to have modeling and simulation. Like you need to know how to design something on like um, SolidWorks or CATIA and all of that, right? You need then after modeling, you need to now know like analysis skills, that's simulation, and of course MATLAB can pass because you have Simulink on MATLAB. We will to do some block diagram nonsense and some other things. Of course, MATLAB you can say Simulink, MATLAB Simulink is a simulation tool. There's also there are other ones. There's ANSYS. That's depending on the project you are doing. There is ANSYS. There is Adams software. There is basically different types, different softwares, different skills, right? But again, like I said, you don't exactly need to be like a guru level in all of those things. It's just that you are able to produce like research. For example, me, for example, it's not as if my Python, not as if I code every day on Python, like I code on Python every day, no. But I know that if I'm collaborating with someone and maybe my own part was a part of maybe writing mathematical equations, and then my friend, his own part is to convert those mathematical equations into into like code, right? If my friend comes to meet me and he shows me the work, via reading through the codes, I should be able to understand that, oh yeah, this person definitely did, like this person is actually like this person is like is on track. The person wrote a very good code, right? But if you're not knowledgeable in like maybe Python or something, how do you want to what if the guy just chatted rubbish for you, and then do you get so it's for your personal good and it's for the good of when you're collaborating with someone that you like that you learn skill is very, very important. It's very important, please. And of course, it's you are doing research. So if you want to do a project, what do you want to work on? You can't be writing review papers all the days of your life. You need to do something more technical. Maybe build something like assemble things together, maybe assemble a drone together and they understand, okay, this particular drone, if the speed of the rotor is 100 RPM, what is the velocity? Okay, let's increase the RPM to 500 RPM. You study the dynamics of the drone, increase it to 1000 RPM, study the dynamics of the drone. Basically, you get super. But in essence, you need skills. And how do you do that? Of course, I don't exactly go to myself and say, "Oh, I'm looking for something." No, me, I have a very good friend of mine, Victor Adeleke. In fact, we do a lot of discuss. I can just call Victor today. Victor Alpha, let's think of this thing together. I watched a TikTok video and I saw this particular aerospace robot, like it was able to open his clinic on it, like, and that's true. What if we do a project, we design something similar, and then we simulate on answers, and then we this and that, and then we submit it to a particular, like you get. So basically, again, it comes with curiosity. You cannot pour from an empty cup. You need to know what you are doing, right? So now I don't exactly post on my Twitter and say I'm looking for some. No, I mean I think you're in OAU, so maybe in your course of project, maybe when you get to part 4 and part 5, you get to work in a group of, like, in a team. Because for example, we in mechanical engineering department, we will do projects via, like, since part 3 and at any level we do course of projects, 400 level, even this part 5. Aside from our final year projects, we did about 2 or 3 other, like, projects to get. That paper I showed you now was a project I did in the first semester, and I did another in the second semester. So basically, you just need to get involved. You just need to get involved in your department. When they say come and do projects, don't run away. And aside from that, you go and meet your professor. Oh, Professor Oluwatosin, Professor this, Professor that. I see you are working on this. How can I join your? Maybe how can I help you out? Is there any skill you are looking at? Like, is there anything that you think I can fit in your? Basically, you just need to reach out to people. Hi, Glory. I see that you are working on this. I'm interested in this. Can we work together? And that's why LinkedIn is important. It's on LinkedIn that you get to, like, see what people are doing, and then you reach out to them. So again, you need to have skills, and then you need to reach out to people. So I hope that answers your question. Yeah. So does anybody else has a question? I think Nancy says she has a question.
Yes, I do. So I didn't join from the
Okay.
beginning, so I don't know if you have answered this, but
Okay.
I would like you to, like, explain to me or us how, like, collaboration in research looks like what is the criteria
Oh.
for, like, being the first author, second author, like, is it that the
Oh,
first
okay.
author is the, yeah, and
Okay.
also,
Okay.
like, how do like, when you're collaborating with others, how best is it to, like, divide the work so that you guys can achieve the goal faster? Thank you.
Okay. Yeah. In fact, that's one of the biggest questions anybody can ask, because the issue of first author, second author is very important, right? Now, you need to. Okay, let me start like this. Now, of course, I'm giving, because based on my own experience, that's what I'm going to share to you guys, right? In the future, it might change, but I doubt that, right? Now, the person who proposes the work, the person who said, "Oh, I'm thinking about this," that means definitely the person is probably going to be the person that will do most of the technical things, right? Now, say for example, you proposed a work on NLP for different African languages, right? Of course, you have the skills, you have the coding skills, you have all of that skills, right? Right. Now, if you have a teammate, if your teammate also has, like, like a skill in NLP or machine learning and all of that, right? That means both of you have, like, similar skills. You need to ask yourself that question of, between me and her, who actually worked on this project more? This project was quite demanding, yeah, but who worked more? Like, who did something more, right? You have to be honest about it, please. You have to be honest about it. But again, of course, you might want to be general and say, okay, let me give that girl the first photo. Let me just become second author. You can do that. I mean, it's your choice, but you need to ask that question of, between me and her, between me and him, who actually did bulk of this work right now? That's if you are two. But if you're like 5 or 6, right? And let's say, for example, you share the work amongst yourself, right? Of course, those tasks cannot have the same weight. They cannot have the same weight. You should answer me and say, let's say, for example, you delegate tasks among your teammates. Those tasks cannot have the same weight. They actually can't. They can't have the same weight. Now, you want to ask yourself the question of, now, this task, you weigh it. Which one weight more? And then you look at the person that you gave the task to. How did the person deliver? Did the person actually hit the nail on the head, or did you yourself, as the instigator of the work, did you add to, like, add something extra to it, right? Do you get my point? So basically, you need to give that balance between the task that was delegated and the person that delivered it. If, for example, like maybe the person had like a very technical task, and then the person delivered very well. You just give that rating scale for each of your members. Okay, oh, member A this, member B that, member C this, member D that. Oh, this is his task. Over 10. What did the person score? Ah, no, this girl stressed me, but she actually did the work perfectly. Let me give her a 9.5 over 10. The rigor of the task. How tough was the task? Okay, that was actually very tough. Let me say rigor 10. You go to the next person B. This person, because is not doing this person stress. This person the person I had to still like adjust some of the things that can, like, it's from there that you get to know all of these things. Honestly, it's not exactly hard, but it's very important. Again, you need to discuss with them. Look at this. I'm going to be the first author. I think based off what everybody have done, I think it makes sense if Blue is second author, and if Sylvester is the third author, and if Chidera is the like fourth author. Because I mean, because based off if we have to rank things, I think I did most of the work. I contributed most of the things, and the second author did a little bit more, a little bit less than what I did, and all of that. So basically, it's not exactly hard. It's not exactly hard. So yeah. Um, I think you asked two questions. I can't remember the other question that you asked.
I said that how do you like delegate tasks while working
Oh, okay.
together?
Okay. How do you delegate? How do you delegate tasks? Okay. Now we are in the world of AI, so you can just say, AI, please, based off this my methodology, or based off the what we are working on, right? We are in a team of 5, and you just input the. I'm giving an example. Right? Just give GPT. Okay, no, see, she is an expert in NLP. She did it. She did that. Right? Person Sylvester is an expert in research writing and this and that and everything. He also knows how to structure this, how to do that. Put it there. Person C, oh, Simon, he is actually like a mathematics person. He knows like how to, do data analysis and stuff and all that. Okay, put it there. S&D. So basically, I mean, these are legit ways of using ChatGPT, of using AI. Please, AI is not bad though, but of course, there are things that you guys do with AI that is very, very bad. But for things like delegating tasks, please, you don't have to be giving yourself a headache. Please, people do it. Even if I do it, just say, AI, please. These are the team members. These are our strength. These are our weakness. Can you do this? And I mean, if you don't want to go the AI part and you want to just discuss it physically, that one's so self day. You as a lead, you should be able to understand what your teammates can do. Say, for example, me and my friend Victor Adeleke, we are working on something, right? I I know Victor's strength and weakness. Let me say, I know Victor's strength and weakness. Victor knows my strength and weakness. Is it only when we write from our head that is not considered plagiarism? Even if you might write from your head, but someone else might have written that thing in a particular paper. Like you for yourself can't say that. Say, for example, you can't just wake up and say, um like, what's the particular niche idea? Okay, NLP does a more better job. It's 95% accurate. But no, you cannot wake up and say that, right? You have to go and check. So someone might have actually said that before, and that is why doing literature review is very, very important. Like, doing review is actually very, very important. So of course, again, you need to do literature review. and then you cite them. But of course, there are some things that you don't have to cite, like some common knowledge. For example, now in my case, if you say something like CNG is a safe kind of engine can come. I mean, that is not I mean it's not new knowledge, so you don't have to cite anybody, you don't have to reference anybody. Just like that. I mean, everybody knows that CNG is a cleaner form of cleaning than petrol and stuff. So you don't have to cite that. That's just redundant. So yeah. So another person asked another question. Hope that answers the question on say. Yeah, another person has another question of
Yes, it does. Thank you so much.
okay. Oh, but another person has another question of, can we use ChatGPT to summarize the abstract when reviewing? Can we use ChatGPT to summarize the abstract? I don't understand what that means. Summarize the app. Can you explain what do you mean by summarize an abstract? Or do you mean draft the abstract? Anyway, I will just assume you mean you mean draft the abstract, right? So I mean, okay. To review the output of someone else's work. Yeah, you can, but you are only deceiving. You are not doing yourself any good because I mean, you yourself want to be better at doing research. So why are you laughing? I'm actually being serious, right? You yourself want to get better at doing something. So you can't always rely on GPT to help you review. You yourself need to open it and really think about it. Do it by yourself. Because if you keep telling GPT every time, you won't exactly learn for yourself. Like you're just going to be doing it for the sake of the work. Like you won't have any personal, like it's not going to have any personal, like personal something to you. Like you won't exactly gain a lot of things. So of course you can use GPT if you're starting out. I don't know. And then of course later on you start for yourself. Oh, okay, let me even try to understand by myself what these people did. That way you are learning. So do you understand me, Ibrahim? Who else? Someone ask a question. The moderator, please, maybe so you can start telling us that our time is up or something like that. So does anybody has any question based on anything? You can ask me anything, anything, please feel free. Okay, yeah, you can speak, yeah, feel free.
Okay, good evening. So I have a question, and it is concerning reviewing of abstracts.
Okay.
No, reviewing of papers, I mean, sorry. So in reviewing papers, like, I mean, if I'm to review someone's paper and I really want to go and like put in my own research paper that, okay, what this person has done, he achieved this result, and I also did my own, I achieved this result. It's more like
Mm-hmm.
comparing. There is something I'm trying to understand, because if I'm to, let's say I want to review a lot of papers to be able to know which one is the right one or which one is the correct one. Is it like I'll be doing the
Mm-hmm.
same type of project like that someone has done before? Then I'll now like comment on it, or I should go and look for another kind of like strategy. Probably if someone use one method and they have this result, and me I use another
Mm-hmm.
method, I have another result. Like is that like, let's say for example now
Okay.
my own result is it now even less accurate than the person's result?
Okay.
Do you think it's still a good
Mm-hmm.
idea to publish that kind of work?
Why not? Now, let me put this out there, right? Normally, research is supposed to push the boundary of knowledge. Research is supposed to help push the boundary of knowledge, right? But again, research is also for us to learn and for us to understand what is going on in that particular field, right? So if someone did a particular work, you go through what the person did, right? The person used this method A, he got this result, right? You can say that you too, you want to do your own. You want to use the method that they used, and then you do your result. And then when you're writing, you're not so okay, oh, they did this and then they got this. Me, oh, I did this and I got this. It is your own. I mean, she didn't want to beat you. Nobody wants to query you for doing a research, and then you have your findings, and then you reported it in you publish it in a conference. It's your research, so own it, right? But again, you it's not really advisable to just do a copy and paste of what someone else has done, right? Even if it is one thing you want to tweak, even if it is just one thing you want to tweak, just find a way to tweak it. If they use method A, okay, let's say for example now, I want to like understand, maybe let me use aerospace now. Let me just use aeroplane, right? I want to understand, I want to understand the the impact of drag force on an aeroplane. Go and look at like a particular paper. If a particular paper used a Boeing 737, they used this particular method and then they got their result. You can say you will use that same method though, but instead of Boeing 737, you will use Airbus A380. Even if it is just one thing you want to tweak there, just tweak it and get your results. That's what concerns you. You don't have any problem with if someone else is saying that. No, but at least just find a particular place that you can come in. Just find that particular place that you can come in. Do you get my point? Yeah.
All right, Samiat, has your question been answered? All right, so moving on quickly, I want to say thank you so much, Mr. Kolade. That session was genuinely refreshing. And I really like how you broke things down in a way that made research writing feel a lot more approachable, right? And a lot more approachable and a lot less intimidating. So thank you very much. And one thing I would really like to commend is the time and work you put into your slides, because I could really see and it was really obvious that you put a lot of work and time making those slides, and that is really commendable. And I really love how you moved from the foundations to the practical steps. You didn't just talk the talk, you also walked the walk, and that was really amazing. And thank you so much for the answers to the questions you gave, because after your session we're supposed to have a question and answer session, but you interweaved the question and answer session into your session. And honestly, sessions like this are what we need as students: something real, something relatable, something that doesn't just teach but actually motivate. So sir, we appreciate the time, the insight, and most especially the intentionality. Emphasis on the intentionality you've shared with us this evening. So guys, a round of applause. A round of applause. A round of applause for Oluwatosin Kolade. Thank you very much, sir. Thank you so much. So,
No,
unfortunately, yes.
no, I said I said you are welcome. It's my pleasure. It's an honor.
All right. So, unfortunately, we won't be able to take any more questions. So, moving on quickly. All right, so moving on quickly, we'll be taking our announcement. So after this session, I'm sure we've all gotten how to write research papers and all that. So in the light of that, Nais is putting out the call for abstract. So this is your chance to showcase the research you've learned. So don't sleep on this, guys. Also, we'll be having our SPE photo day. If you're excited, can I see your virtual reactions, please? All right, thank you guys. Thank you guys so much. So we'll be having our SPE photo day on the 23rd of November 2025. You do not want to miss it. So if you are on the photo day participant group, please make your payment soon, because we have just 50 slots and those slots are very limited. After 50 slots, that is it. And if you've not been added to the photo day participant group, please let us know. Also, we'll be having our November SPE Lagos monthly technical meeting, right? So I really want each and one of us to be there. So thank you once again for each and every one of us that